Shumsauce Incorporated gets ready to make their monthly delivery to Australia. However, there has recently been violent outbreaks and fighting across the globe due to recent shortages of shumsauce sauce. For this reason, the company has decided to take precautionary methods in their delivery and switch to a smaller, less noticeable plane, rather than their usual large cargo one. In order to fit the maximum amount of cargo in the back of the plane, the company decides to use triple integrals to find the volume of the cargo-carrying section of the aircraft. They know the section can be expressed as the region under 3y squared plus 3x squared plus z squared equals 39, and inside the cylinder x squared plus y squared equals 10, and also bounded below by the z equals 0 plane. Since we will be using polar coordinates, we must first find the bounds in polar form. We set the equation 3y squared plus 3x squared plus z squared equals 39 equal to z, giving us z equals the square root of 39 minus 3r squared. Since we know x squared plus y squared equals r squared, we now have our z bounds, which is 0 is less than or equal to z, which is less than or equal to the square root of 39 minus 3r squared. Since we know x squared plus y squared equals r squared, we can derive r equals square root of 10 from x squared plus y squared equals 10, giving our r bounds. 0 is less than or equal to r, which is less than or equal to the square root of 10. Because we are bounded by our cylinder, we will use 0 is less than or equal to theta, which is less than or equal to 2 pi, for a theta bounds. Since we have all of our bounds, we can finally set up and solve our volume equation, which is listed in part 3. We then integrate with respect to z, and we get the following equation. However, we must now use the u substitution to solve the integral for the next part. Using u substitution, we substitute 39 minus 3r squared in for u and take the derivative, giving us du equals negative 6r. We then plug u du in and differentiate. We then plug 39 minus 3r squared back in for u. We now have our final equation. We can plug in the integral from the u substitution back into the original integral, and we can solve the last part as a regular integral. Our final answer is 453.552 meters cubed, which is the volume of shumsauce sauce our plane will be able to hold. Once the maximum amount of cargo is loaded onto the plane, Shumsauce Incorporated takes off for Australia. The flight is going smoothly until the pilot notices a red light flashing. The plane is out of fuel. This light indicates that there is only 10 minutes left of fuel. The pilot is worried because he is currently flying over an island and is unsure if he will make it the remaining 160 meters to the ocean to safely land. Knowing the equation for the path of the plane to be r of t equals open parentheses 3t cosine t close parentheses I plus open parentheses 3t sine t close parentheses j plus 2 square root 2 of t to the 3/2 power k, he decides to use arc length to determine how far the plane will go. If he is unable to make it over the island, he will be forced to jump from the plane, which could be very dangerous. To find arc length, he must find the integral from a to b of the square root of each component squared. First, he finds the derivatives of x, y, and z components, which gives him open parentheses minus 3t sine t plus 3 cosine t close parentheses I plus open parentheses 3t cosine t plus 3 sine t close parentheses j plus open parentheses 3 square root 2t close parentheses u. Now he can set up the integral from time 0 to 10. He can then simplify by adding 9 cosine squared t plus 9 squared t, which is 9, and adding 9t squared sine squared t plus 9t squared cosine squared t, which is 9t squared. This simplifies out to the following integral. He factors is able to get rid of the square root, simplifying out to the integral following. Now he integrates, and the final distance is 180. This means he will be able to make it the 160 meters and safely land the plane in the ocean. The pilot is able to swim safely to shore, making sure to bring his cell phone with him. However, when he reaches the shore, He has no service. He decides he must climb the mountain range, which is represented by f of xy equals x over 3, open parentheses, cosine squared x plus sine squared y, close parentheses squared, in order to reach cell service. However, the island is swarming with people who would do anything to get some Shumsauce. Fearing for his safety, he decides to calculate the path of steepest ascent in order to move quickly to reach the top and call for help. The mountain range can be viewed by this 3D model. To find the gradient, he must find the partial derivatives of z. The partial derivative of z in respect to x is 0.484529, and the partial derivative of z in respect to y is negative 0.775777. With this information, he is able to determine that at his current location of square root 3, 2 pi over 3, the gradient is equal to 0.484529i minus 0.775777j. Upon reaching the top, he is able to find cell service and call for help. Help arrives just in time, and he is rescued at last. Shumsauce will live forever.